Welcome to this video on Introduction to Graphing Quadratic Functions, the Parabola. This is part 2. In our previous video, we discussed some of the basic information associated with quadratic equations. Now, in this video, we're going to start our first example. Notice we've been given the graph of a quadratic function, and it's right here. So what we want to do is we want to go through and use this graph to answer the questions that we're given. So the first question says, does the graph open upward or downward? Well, it's very easy to see that it opens up. In other words, if you poured water into it, it would hold water. Okay? So we can say that it opens upward. It says if the equation of the graph is given in the form f of x equals ax squared plus bx plus c, is the value of a positive or negative, and how do you know? Well, in the last video, we learned that if a is positive, that means the graph opens upward. Well, our graph opens upward, so therefore we can reason that a is positive. In other words, a is greater than 0. Then it says, what is the y-intercept of the graph? Well, we don't really have to do any math. We can just look at the graph. So here is the y-axis. Where does the blue parabola intersect the y-axis? If you said it's at this point right here, that is correct. What is the ordered pair associated with that dot? Well, the ordered pair is x equals 0, y equals negative 8. So that is our y-intercept. Notice that these points have to be written as ordered pairs. Then it says what are the x-intercepts, if there are any? Well, now we need to figure out where this graph crosses the x-axis. So to me, it looks like it crosses the x-axis here and here. Now, it's a little bit unfortunate because it looks like the graph itself is obscuring those numbers. So this number right here, I can sort of almost see it, is negative 2. So that's the point negative 2, 0. And this number right here, also a little bit obscured, is the point x equals 4, y equals 0. Okay, so those are the two x-intercepts. Now they want to know what is the vertex of the graph. Well, the vertex is either the highest point or the lowest point of the graph. In this case, this is the lowest point since the graph opens upward. So what is the ordered pair associated with that point? Well, in order to get to there from the origin, we have to go to the right 1, so x is 1, and then we would have to go down 9 units, so y would be negative 9. So 1, negative 9 is the vertex of our graph. Last but not least, it asks for the equation of the line of symmetry. Again, in the previous video, we learned that the equation for the line of symmetry is negative b over 2a. Now, we don't have the equation of the line, but we do have the graph. So let's see if graphically we can draw the line of symmetry. So a line of symmetry, it happens where basically if I folded this guy over on itself, then it would match up, if that makes sense. Okay, I didn't do a great job of drawing that line exactly. I'll try one more time. It's not as easy as it looks. So there we go. That's a little bit better. Okay. Nope. Let's just do it manually. So the line of symmetry is this vertical line right here. Okay, so you may recall from a previous class or from this equation right here that we're going to have x equals something. And what is that value? Well, you can see here, right, this is x equals 1. So the equation of our line of symmetry, or the axis of symmetry, is x equals 1. So we got all of that just from looking at the graph of our quadratic equation, or our parabola. This time we're going to do another example, but notice no graph, right? All I have here is my equation. So we're going to get the same amount of information, the same questions are going to be answered. However, we're going to answer them just using this equation. Okay? So it says, does the graph open upward or downward? Well, we need to look at a. Remember, we have y equals ax squared plus bx plus c. Well, if we look at this equation, what is next to x squared? Well, it's really 1, right? We could write it as 1x squared. Is that 1 positive or negative? Well, it's positive, right? We assume that when we don't write any symbol in front of a value or a term, that it's positive. So since our leading coefficient is positive, we know that the graph is going to open upward. Similarly, right, we can tell directly that a is positive, right? A is positive 1. You can also write in shorthand, you can just say a is greater than 0. Okay, so now they want us to find the y-intercept. Remember, to find the y-intercept, we set x equal to 0 and solve for y. Okay, so we have y is equal to x squared plus 4x plus 3. Okay, and we're going to put 0 in place of all of the x's, so we have y equals 3. However, we need to be careful, right, because it's not really y equals 3, that's a line. It's the ordered pair 0, 3. So that is the y-intercept, is the point 0, 3. What about the x-intercepts? How can we find them? Well, to find the x-intercepts, we need to figure out y equals 0. So what does that look like? Well, we have 0 equals x squared plus 4x plus 3. We did these a long time ago. And what we can do here is we can actually factor this guy. We get x plus 3 times x plus 1. We can keep going. We have x plus 3 equals 0 or x plus 1 equals 0. If we subtract 3 from both sides, subtract 1 from both sides, we have either x is equal to negative 3 or x equals to negative 1. However, both of those are lines and not ordered pairs. So we need to write our x-intercepts as ordered pairs. How can we do that? Well, we already know y equals 0. So one ordered pair is negative 3, 0. I picked this negative 3 and this 0. And a second ordered pair is negative 1, 0. So the 2 points, the 2 locations on the Cartesian plane where this crosses the x-axis are negative 3, 0 and negative 1, 0. All right, the next question says, what is the vertex? So remember, we need to memorize this equation, x equals negative b over 2a. Well, what is a and what is b? Well, remember there's a 1 here, so a is 1, and b is 4. So that means that x is equal to negative 4 over 2 times 1. That's negative 4 over 2, or just negative 2. Well, we have a problem here, right, because our vertex is x equals 2, y equals something. How can we find the y value of the vertex? Well, what we do is we have y equals x squared plus 4x plus 3, and we take that value of negative 2 and we simply substitute it into this equation. So let's go ahead and do that. So we have negative 2, negative 2. So negative 2 quantity squared is 4, so we have 4 minus 8 plus 3. That gives us a value of negative 1. So now we can finally write that the vertex is negative 2, negative 1. And then, what is the equation of the axis of symmetry? Well, we actually already did that. We don't have to do any extra work because we already have x equals negative b over 2a, right? We already found that. We know that this is the equation x equals negative 2. So notice that the equation of the line of symmetry, right, is x equals negative 2, is the same as the x value of your vertex. Because why? Well, remember in this last example we found that the line of symmetry, or the axis of symmetry, passes through the vertex, doesn't it? Okay, so the x value associated with the vertex and the equation of the axis of symmetry are the same values. So now what we can do, now that we have all this information, we can take all of this information and we can put it on our graph. So let's go through what we have. So one piece of information is that we know that our graph is going to be oriented upward. So when I sketch this, notice that I'm going to be sketching it so that it looks like this. It's not going to be sketched like that. Okay? So that's the first piece of information. Then I have a y-intercept of 0, 3. So let's go ahead and plot the y-intercept on this graph. 0, 3 is right here. That's my y-intercept. Okay, then we have our x-intercepts. Our x-intercepts are negative 3, 0 and negative 1, 0. So let's go ahead and plot those on the graph. Negative 3, 0 is right here. Negative 1, 0 is right here. And let me change the color so we can see it really well. So here's negative 3, 0. Here's negative 1, 0. That's better. Okay, so we have our y-intercepts and our two x-intercepts, but we're going to need some more points. So another point that we have is our vertex. Our vertex is negative 2, negative 1. So let's draw that. The point negative 2, negative 1 is right there. Then the last thing I'm going to do is I'm going to sketch a line to represent my axis of symmetry. So let's see if we can do that. So remember, the axis of symmetry passes through the vertex. Okay? So the reason the axis of symmetry is so important when I graph this is because I know that this is all of the points on one side are going to be mirrored on the other side. So for example, notice that this point and that point, right, aren't they, they're equal distant from the line of symmetry. Okay, so I can also make the same assumption with this point. So there has to be another point over here that is balancing that out. So I have 5 points now, and what I can do is I can sketch a very rough sketch here by connecting these in a smooth curve, okay? And my graph is going to look like that. Now, if I wanted to, or if I was asked to, I could create a table of values, and that table of values would help me fill in some of the points above, okay? But for right now, we're going to just say that this is enough, okay? And we're going to stop here with these 5 points, and that's going to be a sketch of a parabola. All right, let's do another example. So now that we've gone through one example, I really want to encourage you to pause this video, try this example on your own, and then unpause it and see if you are correct. So first it says, does the graph open upwards or downwards? If we look at our leading coefficient, we can see that the leading coefficient is negative. So since a is less than 0, the graph must open downward. So that means if I were to sketch it, it's going to look something like that. Okay? Then it asks, what is the y-intercept? Well, we find the y-intercept, remember, by setting x equal to 0 and solving for y. So we have y equals negative 9. However, y equals negative 9 is not a point, but a line, right? So we need to write it as an ordered pair. So the ordered pair, remember, is x equals 0, y equals negative 9. Then it asks for our x-intercepts. Uh-oh. Well, how do we do that? Well, we probably need to factor this. So if you think back to your general factoring strategy, the first thing we do is factor out. So I can factor out a negative 3. So that's going to give me x squared minus 4x plus 3. Okay, and remember we want to set it equal to 0 and solve. So I can get rid of this negative 3 by basically dividing both sides by negative 3. So now I have x squared minus 4x plus 3 is equal to 0. So now we need to factor it. So we have x minus 1 times x minus 3 is equal to 0, which means our two solutions are either positive 1 or positive 3. Once again, I remind you that these are not ordered pairs yet, so we need to write them as ordered pairs. Right, we got them by setting y equal to 0. So our two x-intercepts are 1, 0 and 3, 0. Again, that's going to be important when we go to graph them on the next page. All right, the last two questions are really the same, right? So the equation of the of the axis of symmetry, I'll do that down here. I'm going to do this one first. I'm going out of order. Okay, so remember A, we have to go back to our original equation. Okay, so don't go back just to here. That's not going to get you the right answer. You have to go back to the original equation. So the original equation is that A is equal to negative 3, and in the original equation, B is equal to 12. So we have negative 12 over 2 times negative 3. So that's going to be negative 12 over negative 6, which is positive 2. Okay, so now we know that the vertex is 2 comma something. How do we figure out that something? Well, we actually plug it in to our equation. So anytime I see x, instead of writing x, I'm going to write 2. Okay, so I have negative 3 times 2 squared. Well, 2 squared is 4. Then I have 12 times 2, that's 24. So now I have negative 3 times 4, so I have negative 12 plus 24 minus 9. That gives me 12 minus 9, or 3. So now I can fill in the other value here. So my vertex happens or lands at 2, 3. Okay, so now I have all the information that I need, right? I know that the parabola is opening downward. I know that the y-intercept is 0, 9. My two x-intercepts are here. I know the vertex is this point, and I know that the axis of symmetry is x equals 2. So let's see if we can take all that information and put it on our graph. So first I'm going to draw the y-intercept. The y-intercept is here at 0, -9. Then my x-intercepts are at 1 and 3. Okay, so I have an x-intercept at 1 and x-intercept at 3. Okay, then my vertex is at 2, 3. So here is my vertex right here. Okay, then I'm going to draw my line of symmetry, because remember, I can reflect any point across the line of symmetry to generate a point on the other side. So these guys, as you can see, are already reflected. My vertex lands on the line itself. The only other point that I can reflect is this guy right here. So I'm going to erase this because he's kind of in my way. So I'm going to put another point right here. So now I have 5 points. That's a nice number of points. And I'm going to very carefully sketch this so that it looks like a parabola. Okay, so that's it. All right, let's do one more example. So the question says we have f of x, or y, equals x squared minus 2x minus 8. So again, we look at a. Our leading coefficient is 1. So this guy is going to open upwards, okay, or up, right? We know that because a is greater than 0. So the next part says, what is the y-intercept? We find the y-intercept by setting x equal to 0 and solving for y. So we have y is equal to x squared minus 2x minus 8. So we have 0 squared minus 2 times 0 minus 8. So we have y equals -8. But remember, we have to write this as an ordered pair. So that's going to be the point 0, -8. Then they ask, what are the x-intercepts? Well, to find the x-intercepts, we need to use the AC method to factor this polynomial. It factors as x minus 4 times x plus 2 is equal to 0. So my two solutions are positive 4 and -2. Remember, we have to write both of those points as ordered pairs. So we have the point 4, 0 and the point -2, 0. Then I'm going to skip to the bottom and I'm going to write the equation for the axis of symmetry, that is -b over 2a. Note that a is 1 and that b is -2. So this is a little bit tricky, right? Because I have -b over 2a, but my b is already negative. So I'm going to have -2, be careful with your signs, over 2 times 1. Well, what happens when you have two negative signs next to each other? Well, they become positive, so we just get 2 over 2, which is just 1. Okay, so my vertex is 1 something. To find out what that something is, I have to put 1 in place of x in my equation. So I have a 1 and a 1. 1 squared is 1. 2 times 1 is 2. So I have 1 minus 2, which is -1. And then I have -1 minus 8, which is -9. So my vertex for this equation, or for this parabola, is positive 1, -9. Okay, so I'm going to take the fact that this graph is opening upwards. I'm going to take the fact that the y-intercept is 0, 8. My x-intercepts are here. My vertex is here. My line of symmetry is x equals 1. I'm going to take all this information and put it on my graph. So let's begin. So my y-intercept is 0, -8. That's right here. Okay, my two x-intercepts, so that was my y-intercepts. My x-intercepts are 4, 0. So 4, 0 is right here. And -2, 0 is right there. Okay, my vertex is positive 1, -9. So positive 1, -9 is right here. Okay, and then I'm going to sketch that line of symmetry. And again, the reason I want to have that line of symmetry is because any points on either side, I can reflect to the other side. So I want to reflect this point onto the other side, and so I get this other point over here. Okay, so I have 5 points, and now I can connect them. It's a little bit difficult to draw or to sketch my parabola. Okay, and again, if you wanted to fill in this part of the graph, you could create a table of values and generate more points so that you'd have a more accurate graph. But for right now, we're saying that this is fine, this is sufficient, and we're done graphing this one.